Okay, so on note 6.4, we're going to be analyzing graphs of quadratic functions. So similar to what we've been doing with the different forms that we've looked at, standard form, root form, and vertex form. So we're going to be looking at those same forms still graphing, but we're going to be analyzing the graph and having to come up with domain, range, and axis of symmetry, things like that. Okay, so first thing you need to do on these examples is determine what type of form you have. So if you look at number 1, that would be in standard form. Okay, so on standard form, to find the vertex, you're using the formula x equals negative b over 2a. So I need to use that formula in order to find my x value of the vertex. So notice a is 1, b is 4, and c is 3. Remember, c is also your y-intercept. So plugging in, we're going to have negative 4, because on the formula it's negative b, over 2 times a, so 2 times 1, which would be 2. So the x value of the vertex would be negative 2. Anytime we know x, to find y, we're going to plug it into our equation. So I'm going to come down here. That's going to be negative 2 squared plus 4 times a negative 2 plus 3. Okay, so negative 2 squared is going to give us 4, and then we're going to get minus 8 plus 3. So that would be negative 4 plus 3, which is a negative 1. So there's the y value of our vertex. So I'm going to go ahead and write that in my table. Okay, and then I'm going to choose 3 x values that are consecutive with the x value of the vertex. So I'm going to go larger, so negative 1, 0, and 1. We already know when the x is 0, we have a y-intercept. We already know that's our c, so I can go ahead and fill that in. Okay, so then I'm going to plug in a negative 1. So that's going to give me a positive 1 minus 4 plus 3, so that's going to equal 0. And then I'm going to plug in a 1, positive 1. So that's going to be 1 plus 4 plus 3, so that's 5 plus 3, which is 8. Okay, so from here, I'm going to go ahead and plot it. So this is the same thing as what we've been doing. So negative 2, negative 1 is the vertex. Negative 1, 0. 0, 3, which is our y-intercept and our c. And then 1, 8. Now that's only half, so I want you to draw your axis of symmetry. Okay, and then reflect those points over to find the other half of your parabola. And then connect your points. Okay, so once we have found our parabola, we're going to fill in all of this information. So let's go back over here. Okay, so the axis of symmetry. The axis of symmetry is a vertical line. So you should always have x equals. If you do not have x equals, then it's going to be wrong. So make sure you're writing x equals, because that tells me that there's no slope. So x equals wherever it crosses the x, which will be the x value of the vertex. So that's negative 2. You're going to determine if what the max or min value is. What you're looking at is the vertex. If the vertex is at the bottom of the parabola, that's a min. If it's at the top of the parabola, that's a max. So since the vertex is at the bottom of the parabola, I want you to circle min, and I want you to look at what that smallest y value will be. So it's the minimum y value. So notice the y value is -1. You can just write -1. That will be the y value of your vertex, whether it be a max or a min value. Okay, so domain. Remember, domain is x. Use your curly brackets. We're going to find the domain. If you look at the x-axis, notice that it's continuous both directions, so it should be all real numbers. Now, anytime you have a parabola that opens up or down, the domain will be all real numbers. Now, on the other examples that we're looking at today, we're going to have some domain restrictions to where we have to only graph a certain x values. Okay, so make sure that you're using a pencil, especially when we get to number 2 and number 3. Okay, so let's look at the range. If you look at your y-axis, notice the smallest value is -1, and it's everything above it. So y would be greater than or equal to -1. The roots are your x-intercepts. So it crosses the x at -1 and -3. So -1 and -3 would be your roots. Okay, so let's move on to example 2. We first need to figure out what form. Notice this is in vertex form. Okay, so the vertex, when you're in vertex form, is h and k. So notice h is 2, and k, notice that we're not adding anything after the terms that's squared. So k would be 0. So we're going to transfer that to the table. 2, 0. Okay, so then we'll choose 3 consecutive x values, so that will be 3, 4, and 5, and then we'll plug in. So that's going to be y equals 3, and then 3 minus 2 squared. So that'll be 1 inside the parentheses, squared is 1, so that would just equal 3. Plugging in a 4. It's going to be 2 squared, which is 4 times 3 gives you 12. Since that one's going off, this one will also go off. So that's 27. Okay, so when we are graphing this, our vertex is 2, 0. And then we have 3, 3. 4, 12 is going to go off the graph, so we'll draw our axis of symmetry line. And then we'll reflect that other point over. Okay, so axis of symmetry. Remember, axis of symmetry line is always x equals. If you don't write that, I will count it wrong because it doesn't, if you just put the number, it doesn't tell me that it's a vertical line. So x equals wherever it crosses the x-axis, which is the x value of your vertex. So it would be x equals 2. Okay, so your vertex is at the bottom of the parabola, so that would be min. So I'm going to circle that. And then that minimum value is the y value. So the smallest y value that's being used is 0. Now, on the other two, or on number 1, I told you that domain of a parabola that opens up or down is all real numbers. Okay? Now, on number 2 and number 3, you're going to have a domain restriction, which means you're only going to be graphing what your domain says. Okay, so your domain is going to be given to you. So what this tells me here is that I only want to graph x values that are in between 1 and 3. Okay, so look at your x-axis. Here is x equals 1, here is x equals 3. We only want to graph in between, or the parabola that has those x values. So you will need to erase, that's why I told you that you need to be using a pencil. So you will need to erase once you get to x equals 1 and x equals 3, because we don't want anything past that point, but we do want everything in between those two. Now, notice also that it does say that we want it equal to 1, so it will be a closed point, and we do want it equal to 3, so it will be a closed point, so we can keep those 2 points there. So when you have a domain restriction, you're not going to have arrows at both ends of your parabola. Now, when you're finding your range, you're only looking at the new parabola that you have, so whatever you erased. So looking at the range, look at your y-axis, and notice that its smallest value is 0 and it goes all the way up to 3. So your range is in between 0 and 3. So 0 is less than 3. Notice that it's equal to 0 and also equal to 3. Your roots are where it crosses the x-axis. Notice that it only crosses at one point, and that's at 2. Remember, that's called a double root when it only crosses once. It's also your vertex, which it was, 2, 0. Okay, so on these examples, sometimes you're not going to have a restriction. If you don't have a restriction, we know the domain of any parabola that opens up or down is all real numbers. But if you have a restriction, you need to go back once you've graphed it and only graph the portion that it wants. Okay, so now let's take a look at this third example. Okay, so this form, first decide what form it's in. So this would be root form. Okay, so remember, roots are your x-intercepts. So your R1 would equal 2, and R2 would equal negative 2. Okay, so I'm going to go ahead and plot those where it crosses the x at. So 2 and negative 2. And remember to find the vertex once you know those two roots. The vertex is in the middle, so the middle x value in between those would be 0. So we know the x value. Now to find the y value, we're just going to plug in. So that would be negative 2 times negative 2 times a positive 2. So that should give you 8. So there's our vertex. And then we're going to choose 3 consecutive x values, so 1, 2, and 3. Notice that on the graph, we already have a root at 2, so we know that's going to be a 0. And then we'll plug in the 1. So that's going to be negative 2 times a negative 1 times 3, so you should get positive 6. Okay, and then plug in 3. So that's going to be negative 2 times 1 times 5, which would give you a negative 10. Okay, so let's go ahead and plot those. So we're going to have 0, 8 is our vertex, 1, 6, and then 2, 0 we already had, and then 3, negative 10. Draw your axis of symmetry line, and then reflect. going to go ahead and draw this. If you want, you can go ahead and look at your restriction or go ahead and draw it and then erase it. Okay, axis of symmetry is always x equals wherever the axis of symmetry crosses the x-axis or it's the x value of the vertex, so 0. Notice the parabola is at the top this time, so it should be let me circle max. So circle max there. Okay, that maximum value, so the maximum y value is going to be 8. And now let's look at the domain that we're given. So we only want to graph the parabola that has x values in between -3 and 3. So here is x equals a -3, and then here is x equals a +3. So find that part of the parabola. So that would be these points here. So we don't want to go past these points because that's when x is -3 and when x is +3. Okay, now look at equal to, because notice both of them are not equal to on this. It's equal to the -3, so it'll be a closed point, but not equal to the +3. So we want to erase that point and put an open one when x is +3. So if it gives you your domain, then you need to look and see what you need to have on your graph. Okay. All right, so now let's look at the range. So your range, look at your y-axis. It's in between, there's a starting and stopping point because we have a restriction here. So it's in between, this is 8 and this is -10. So your y is in between -10 and 8. -10 is less than, so we should have less than signs. And notice it is equal to 8. It's also equal to -10 because we have a closed point and an open point. So make sure it's equal to both. The roots are your x-intercepts. That's included on our restriction that we have. So that's what we found at the beginning, 2 and -2.